Hello,
Hi, Professor.
how are you?
Thank you. Fine, and you?
I'm okay. Any question?
Yes, I have for the term project. I have a question. I watched your videos, but still, I have you provided us for this. Oh gosh.
You handle it, yeah, no problem. Take your time, okay? No, don't worry. Yeah.
Somebody's calling from my family.
Yeah, no problem. You
Sorry
can
for
take
that.
it. Yeah.
They don't know I have a meeting.
Yeah, it's okay.
For the term project, I watched some your example and the examples on the blackboard, and you said something of the subblack. You recommend like this one to watch and learn about that and to do it. It means, or from these three examples, this is what you are expecting from us students.
On the term project, any project regarding programming language is acceptable. Those three are just examples.
Oh, just examples.
Yeah, just examples. So that's actually look at this course. This course main idea is to learn programming language, right?
Okay.
The main goal is to learn programming language. So what's the purpose of learning this course? It is like you need to design language, design a new language.
Okay.
And then also to implement the interpreter or compiler, right? That's the whole purpose of doing this. And when are we going to use this? Is something like, okay, for example, sometimes you need to design speech recognition. So there's a person keep talking, right? Keep talking, and then there's some sort of signal, okay, audio signal, speech signal, right? And then we do the so-called speech recognition, right? So speech recognition based on the pattern, they need to translate into text. So the translation between signal to here, you not only sampling the data, but also you need to verify whether it's A, B, C, or whatever. That's a translation. That's a process of the translation, right?
Yeah.
So that's the first translation it may happen. Second translation is like, okay, from this text now, okay, say you are talking to a Echo, Amazon Echo device. So, okay, I need a computer, say you talk to you have a speech and you translate to text. And then this data actually transmit to Amazon, and Amazon look at the keyword computer. So it actually decided to give you some Dell computers websites, for example. Okay, so this one is a question and answer session. So in there, you read in the data, you actually process it and match the best website and return to it. So this is actually a interpretation process. So we learn the programming language course because we want to implement the interpreter or compiler. So that's the purpose. So any project in this nature will be acceptable.
Okay.
So as simple as a calculator language, say plus A3, okay, minus 2. So this one you get, say, so set A1. So in this case, you'll be minus this one. 1 plus 3 will be 4, and 2, you get 2. Okay, so something like this will be acceptable. Something that you get some pattern into your interpreter and deliver the result, that would be acceptable.
Oh, it means like something like a coding. You are like translating, compiling that, and
yeah. This is the whole purpose of doing that. You can make it very complicated or you make it very simple. It's okay, but you need to focus on translation. Some sort of translation. So if you look at the first one, scheme translator, that's a translator. Second one, you do have a one instruction assembly. That's also a translator. So what kind of translator you want to pick and what kind of translator you want to actually design, that's okay. So a translator can be as simple as this, okay? Say Google. Google. Okay, so Google's web page is like this, and you type in computer science. So these two words being grabbed by the Google system, so sent to the Google site. And Google site use this tool to search through all the internet and then respond with a page. So this one is also input, translate, and then response. So that's also okay.
Okay, I got you.
Yeah, got it?
Yeah, I got it. Thank you. And the second question, it is about this now first project, what is due the end of the month. I don't got, I watched all this video on the Zoom meeting, all the whole video. I don't understand how the...
You say project one.
Yes, I didn't get...
Project one is number one, you need to actually know how to measure the time, right? You measure the time. So for this, in this example, the program we measure the time right here is just to print hello for 10,000 times. So you should put your sorting here, but you need to measure sorting for say 10 example, 100 example, 1,000 example, 10,000 example, something like that. Okay, totally. Say selection, so you need to provide 5 cases. Insertion, so you need to provide 5 cases, and then each sorting you should have a curve. So we try to plot like this, and different sorting should end up with different curve. And we're trying to study which the performance of the big O notation. Will this measurement comply with the growth rate or not?
Mm-hmm. I did it already, and I only for the one case it is for the in the range of the 10. But I'm now confused when I'm now for the second one for the 100. I'm putting onto the same file for the same function.
Same file. So basically, you can do this. You can do this whole thing copy 5 times.
Oh.
Copy 5 times. So this one 10, 100, 1,000, 10,000, something like that.
But the same code, like from start time.
The same code, but you actually generate different number of patterns for you to do something.
Okay, and for the math lab, when the chart is now, are we putting on the same file because we are measuring that, or it is the another different file by itself?
This one, you actually collect the data, you can write into some table. You can use Excel to do plotting, or you want to use Python program to do plotting. That's up to you.
Mm-hmm. Okay.
Yeah, there's no limitation that you must use a Python to plot it. Last time I do show people that you can use the Excel to do it.
Okay, thank you.
Yes. Any more question?
No.
Oh, okay. How about Selena? You have question? Hello.
I'm just working on the what do you call it? Roman numerals one right now.
Okay. So this week we are talking about because if you guys are run out of the questions, this week we are on chapter 2 or chapter 3. Okay. So basically, let me introduce the whole course one more time. Okay, what's the purpose of doing this the so-called this one, and then let's compare with the UC Berkeley. Okay, UC Berkeley. UC Berkeley CS61. Okay, since other student has no question, let's actually look at this one. So this is a spring 22. Okay, this one is a required course, first course. So it teach, it's called Structure and Interpretation Programs. Okay, so there's another course in MIT. Okay, MIT actually also teach this one called Structure and the Interpretation of Computer Program. It was a sophomore or junior course, okay, but right now it become an elective, so it's no longer being offered, but it was a course, okay, in MIT and using scheme language, okay, using scheme language. But here let's use the use the Berkeley's version as our example, okay. So this course, what we want to teach is, okay, let's look at what the content of the course. Okay, let me, I'm sorry, let me actually look into the weekly schedule and talk about the content of this course. I keep getting the wrong one, I'm sorry. Okay, so let's look at the content of the course. So basically, the week one, I don't know whether you look at the slices or not. Okay, week one is only an introduction. So week one, let me go into the week one. So let's go into the week one. So in week one is only the introduction. Okay, so week one's, it is talking about programming language course by itself. Okay, programming language by itself. So it talk about the different type of language, machine language, assembly language, and high-level language. Okay, so when you go into the college, so let's look at the college computer courses. Okay, so let me bring up the syllabus. Okay, go into the college courses. So college courses like this. Okay, you kind of, if you look at the Foothill College course, okay, Foothill College course right here, they do offer CS 3A, 3B, 3C, right, for Python, 2A, 2B, 2C for C, like C double plus, 1A, 1B, 1C. So basically 1, 2, 3, these 3 series, they cover the basic programming from normal programming to object-oriented programming to data structure and algorithm. So we are expecting you to finish these after high school, okay? And then Berkeley is taking on this one. And this is the so-called structure and the interpretation of computer program. This is this one here. And this one is called 61A. And then Berkeley has another course called this one, I remember it's 164 or something, okay? I forget the number, but it's called compiler design. That actually is more advanced course, okay? More advanced course for compiler design. So what is programming language and what is the compiler design? So here you learn basic loop, for loop, that's Java 1, okay? Or C double plus 1, right? Loop and function and everything else. Level 2, we learn object-oriented. This we know, okay? That's okay. Level 3, we do data structure. So there's a tree, heap, and dynamic programming. That's the algorithm. Knapsack problem. Okay, those are solving problems. So level 3 are data structure and solving problem. Level 4 is the one we are looking at. Is programming language. It actually is talking about the mechanism of programming language. Mechanism. Okay, mechanism of programming. So what is mechanism of the programming language? Mechanism of programming language means you are coming to a environment on translation. So here we have something called machine. Okay, machine. We do have something we call it grammar. Okay, so here you have input. Okay, so input can be some program, can be some ASIC. Okay, so input is a program, is an ASIC, so it's written in certain languages, so Java, or is it written in English maybe? Okay, so some languages. So here, language means the grammar rules. Grammar rules, okay, and the character set, okay, and character set. You have grammar rule, because that's your language. So language including grammar rule and character set. So use the grammar, you design a machine, and then you translate your program to create some syntax tree. So some syntax tree, okay, and then you run on it and deliver results. So you will translate to another language, say from Java to low-level language, or from Java to some bytecode. Okay, so this is the process of translation. And we teach programming language is to talk about the whole concept here, okay, the whole concept here, the mechanism here, the whole mechanism here. So because of here, you involve a lot of software translation. So you need to know about data structure, know about the algorithm, those kind of knowledge you need. And then you put the whole thing together to write an interpreter. So in the so-called Berkeley 61 course, they do have a project. They do have a project here in Optimeton. They do have an interpreter project, okay. They do have some project scheme, language scheme contest. They do have these different topic, okay.
I have a question.
Yes. Go ahead.
So the grammar would be like a programming language like Java or Python kind of, and then the program.
No. Grammar is not something like that. Grammar is different. Okay. So grammar is a set of rules, right? Grammar is a set of rules. So basically your language actually is including grammar and many other things. Okay. So grammar is only part of the language. Okay. You also have keyword. You also have some word. You also have some different things. Okay. So grammar is just for you to set up the so-called a auto checker, the machine. So let's pick an example. So for example, like the regular expression. So regular expression, we say that it's A to D later, right? And 0 or more later. So A, B, okay, C, D, E, these are all 1 letter or more later, right? So that's regular expression. But if you write 1, then 1 is not regular, it's not a regular expression. So this rule that you write down in regular expression, that's grammar, or some sort of grammar. But your language may be written in this way. The AB, the tokens are your language. The tokens are your language. Is that okay?
Yeah.
So the purpose of this one is usually for writing this, taking this language course, programming language course. Usually you have a grammar, you have a machine. Your input program is in Java format, and then you actually either you have interpreter, so you run the program, or you have compiled it to some executable program. Is that okay?
Yeah.
That's the whole purpose. And 61A in Berkeley need you to run it, directly run. They don't need you to do compilation. No. And that compilation belongs to the next one, the compiler course. That's even more advanced. Okay, so this course is teaching you that is. So here actually in the first few chapters, the first chapter is talking about what is high-level language, okay, what is low-level language, what is different programming paradigm. The so-called imperative programming that you know about it actually is basically the Python Java type of the for loop if then else. Okay, those are imperative. Object-oriented programming, we talk about it. We have the data field, we have OOP, we have the inheritance that we know. Then in this C2A, they introduce more on the functional programming. So that's what the scheme language is. Okay. So if you follow my material, continue to study, you will learn it. Is that okay?
Functional programming is just it's literally just like functions and stuff, right?
No, it actually is. Let me show you what scheme is. You follow my course, they will have the material online you can use. Okay. So here, let's see. Here, actually, let me bring up. Let me show you how I write. Okay. So here, let me bring up my Dr. record. Okay. So Dr. record uses scheme language. Okay. One moment. Okay. One moment. I'm putting up the Dr. record. Okay. Dr. record is a scheme language. Okay. What I should say is actually the language was originally named Lisp, and then later changed the name to Scheme. and then recently it changed to Racket. So these three languages are one language, just one language. Is that okay?
Yeah.
Same language. So this one is called Dr. Racket. Okay, Dr. Racket. Okay, so what this language is functional programming. So you kind of may need to study it. Okay, but you just follow my weekly progress. Okay, please just work on the homework. Okay, follow my homework week by week, and then any question you are welcome to discuss here. Okay, so here we have a record. Okay, so here let me do this one. Let me define. Okay, a function called big. Okay, big one. So big one, I'm going to take a x and y. Okay, is that okay? So here actually when we have a big and y, and then we have two value. Okay, we will actually have a condition. Okay, and then this condition will be actually greater than x greater than y. In this case, I'm going to return x. Okay, and another condition is actually here actually it is actually less than condition. Okay, here let me I'm sorry, here should have else. Okay, else I'm going to return y. Okay, so here I would check 3 and 5. Okay, and that's actually run it. Oh, let me see that x condition. I may have missed one. Okay, this condition maybe this. Okay, so this condition should be this. You will actually have this. Okay, so I think it's something that is that condition. So let me see. This else is up to here. Okay, so this else is up to here. Okay, and this one's condition. This one is defined. Okay, let me actually save. Okay, save to. No, let me save it to this one. Assignment demo. Okay, I should have a demo. I'm sorry. I should have a. No, not here. Let me go to here. Okay, right here. Okay, so this is PyDev. Okay, so here we have week 2. Okay, this is discussion. So let me put into week 2 discussion, and this one that's called big one. Okay, so this one is big one. So let's actually run it. Okay, so big one is 5. Is okay? So here actually I will try big one. Okay, 20 and the 7. Okay, so this one is actually save it and run. So this one is called functional programming. Okay, so the functional programming is you actually put the operator, the function here, function, and then data. Okay, is okay? Function data.
Yeah.
So here the first one is to define a function, define function, define by itself is an operator, and what function? The function name is big. The parameter is x and y. Okay, and then you call condition when x greater than y, I return x. Otherwise, I return y. Is okay? 2 conditions. So this is called functional programming. So functional programming is your data A pass to a function, pass through the different function, and pass through another function, and some of the function may be recursion. Is that okay?
Yeah.
So let's see. This one is an easy example, but let me actually bring up more. This one let me save. Okay, save. Okay, let me save it. Let me bring up some bigger project. Okay, some bigger project. Let me bring up some bigger project. I already read it just to show you how things are done. Okay, just to show you how things are done.
Okay.
Okay, that's the language you will need to pick up in this structure and the interpretation stuff. Okay, so here let me go to chapter 9. I have scheme. I do want to have, okay, this one is not what I want to have. Let me try to go to the demo, not demo, project quiz. Let me go to quiz. Week 9 quiz. Okay, so here we do have this record. Okay, this one not going to show you. Let's look at it. Okay, so this one defining the maximum program. Okay, this is a quiz, so I show you already, but I do have other example to look into the binary search. Okay, you can write binary search. Okay, let me try some other project. Let me see, actually, demo program. Okay, no, I don't see that. So you can write binary search, write different thing in Rocket. Okay.
Okay.
Okay, that actually you should be able to find it on internet actually also. So you can also do scheme. Scheme is a dialect of the Lisp. So binary search. Okay, something like that. You should be able to find some program that will do it. Is that okay?
Yeah.
Okay, but anyway, that's an art to write the functional programming. But functional programming is only another paradigm. Okay, that's only another paradigm. But we do have multiple paradigms in programming world. We do have different paradigms. Okay, so that's why we have different language. We have the some language that's actually is declarative, such as the Lisp, Haskell. Okay, as a data flow language. They are large language. They are also imperative maneuver language. They are also object-oriented programming language and scripting language, right? So this portion imperative, we know them better. And this different language usually in school not taught enough. Okay, so this course not only to teach you what are the language available, but also how to design an interpreter for each language. Okay. So here, first one, we go to introduction for a different language and tell you typical language, what will be the feature of the name, scope, data type, and imperative programming, object-oriented programming, and functional programming. Okay, so chapter 2 to 9, we only use Python as example. But Python do have imperative programming, object programming, also functional programming. Is that okay?
Yeah.
And then chapter 9, week 9, we focus on the scheme. Okay, so this the first part of this course is talking about the features of languages. Okay, the features of language. First half. Second half is to look at the interpretation of the language. So we design certain languages. So first half is like, okay, you try to build a car. Okay, so you will say, okay, I want the wheel to be snow compatible wheel. Okay, and I need my engine to be able to run 100 miles per hour at least. Okay, I need my brake to be brake within 0.25 seconds. Okay, those are features, and those are first few weeks topic. So from week 9 and 10 is okay. These are spec, these are requirements, but how we based on those requirements to build a real car. Is that okay?
Yeah.
That's a mechanism we are looking at the second half. Okay.
Okay.
And my course compared to the Berkeley course, okay, let's compare these two courses. Berkeley course is not well organized. So basically they have teach broader than mine. They preach broader than mine, but they actually, all of the lecture are pretty simple. So you have to expect that their content, the material they teach in class is of difficulty 1. what they teach in class. But what you will expect in the exam will be difficulty 10. Is that okay?
Yeah.
So don't expect that what you learn from the lecture can support it. The best way
Okay.
is you keep practicing, keep practicing, keep practicing. Is that okay?
Yeah.
Keep practicing the problem. And there is a website I told you, it's called the so-called the so-called what? Tau Beta Pi. Tau Beta past exam site. You will be able to find the Tau Beta Pi. Tau Beta is the engineering school. And you look at the computer science. Okay, now it's covering the computer science. You should find the past exam for CT1A and midterm final, whatever. Is that okay?
Yeah.
Tons of problem. You find those one with a solution, right? Is that okay? Tons of solution that you can work on. Otherwise, it can be really hard. Okay, it can be really hard. Okay, so that's the same. So far you get started already or no?
I've looked at the slides for the first week so far, and I started on the slides for the second week.
Yeah, this week is the second week, yes. So any questions so far?
Not really.
Week 1 is very simple. Week 2, how about week 2? Week 2 also review of the Python, so it should be okay. But I think
Yeah.
since we'll start to get harder, I believe 3 is okay, 4 is okay. 5, I think 5 and 6 probably still okay. Starting from 7 will become harder. Okay. Starting from 7 will become harder. Okay. So don't worry, just work on them. Is that okay?
Yeah.
Just work on them. Continue to work on them. Okay. And other question?
Not really. Oh, actually, for the Roman to integer one, I've been trying to figure out like how to do it on Studio Visual Code, and it gives me an error that I'm not too sure how to correct.
You can use Java to just write it first.
Yeah, but the problem is like with the map, I'm not sure if I'm declaring it wrong or something, but
yeah, if you sub it, you have a right algorithm say in Java, because at this moment you can use BlueJ to write it out first,
right,
and then you
okay.
try to use C++.
Okay.
And then if you use C++, you still have bug. You can send it to me. I may look at it. Is that okay?
Okay. Yeah.
Yeah, and try to work on it. And then if you still have problem, we may try to help you to finish that and move on to different problem. But not trying to probably about a problem a week or try to speed up a little bit. You know what I'm saying?
Yeah. Okay.
Yeah. Okay. How about other thing? You actually have any progress so far?
I don't think I have any other questions.
Okay, then that's it for today. Is that okay?
Yeah. Thank you.
Bye.
Bye.